Hi there. This is the second part of a set of videos building an environment monitoring station using Pimoroni's Enviro Plus board. In the first video, I covered the hardware and how to put this into the enclosure you see here. In this much shorter video, I want to concentrate on making the front panel cover. This ties in with another of my earlier videos on different ways of making front panels. In that video, I promised to show the process of using lamination the next time I made one. So let's get started. If you have seen the previous video, you know that I had decided to use touch input and made a PCB with 12 touch sensors, replacing the original front panel of the enclosure. Of course, the cover will have to fit the PCB, and the virtual button faces need to match the location of the copper areas. I'm using LibreOffice Draw for that, but in principle any drawing program that lets you create accurately dimensioned printouts will do. To go with the environment theme, I decided to use green buttons, and you can see that basically the 8 buttons here correspond to some measurement value. In hindsight, I regret not having used different colors for the 3 buttons on the left and the big one on the bottom, because they are obviously doing different things, so more visual distinction may have improved usability. It's really up to your taste, and you may wish to add decorations or even use icons instead of the boring old text. Like this one here, which I made just to demonstrate, but now that I've put it together I start to like it. Maybe one of these days I replace the boring version with something like that. It's fairly simple to replace the front cover because it's really only held in place by the power button and the groove that goes around the enclosure. Whatever the design, the last thing I want to mention is that you should duplicate the drawing as many times as fit on a full page, be that an A4 sheet or letter or whatever else the lamination sheets in your country use. You always have to laminate a full page anyway, so it makes sense to fill it with stuff, either front plates of different designs or projects or just copies, which gives you spares in case something goes wrong later when doing the cutouts. The next step is to make a printout of the design. I use normal office type stationery and a laser printer, but an inkjet will work just as well. Now for the fiddly bit. Because we have a display, we need to cut out a window for it in the paper. This is where having multiple copies comes in handy. There are a few decisions to be made here. You see, I decided to cut out a small window for the gas sensor, but that was totally unnecessary since I'll cover it with a sheet of Teflon foil anyway, so there's nothing to see. In fact, even the hole in the PCB is actually not necessary. I decided to cut not a window for the light sensor, because I will punch the hole right through the laminate and paper later. The reason is that the lamination foil would reduce the sensitivity by an unknown factor, and the lux formula is only valid if the sensor is not covered. Lamination pouches come in many qualities and quantities. This pack of 100 is from Fellows and called Enhance 80. The 80 standing for 80 micron thickness, which is their entry-level grade. I used various other brands as well, and always 80 microns, and they all work fine. I never saw the need for thicker pouches. 100 pouches cost around 8 to 9 pounds, so slightly less than 10p per sheet. The next step is to put your printout into the pouch as centered as possible. This can be a bit tricky, but since we will cut out the front plates anyway, the centering isn't as critical as it might be for a document. You need, of course, a laminator, or go to a stationery shop that does lamination for you. This one here is rather old. I had it for ages. Before laminating, you need to wait for the green light on the right to come on, which means the rollers inside have reached the right temperature. Then it's just feeding the pouch in from the front with the closed side first until the rollers catch it and pull it through. The machine recommends not to use a carrier board, and I've never used one. It is important to align the pouch so it goes straight through and does not drift to the right or left. Getting it in slanted runs the risk that it gets stuck, with a resulting mess of half-molten pouch wrapped around the mechanism. Trust me, I have been there more than once. It might be possible to laminate using a hot iron, but I've never tried it. Laminators are relatively cheap, 20 to 30 pounds for a simple one like this, and if you have a family, you find lamination surprisingly useful for all kinds of craft projects. After the sheet has cooled down, it is ready for separating into front covers, and this is what I've done here for the two panels with good cutouts. You can use a craft knife or scissors to cut the sheet. The big hole for the power button can be easily punched out using one of these cheap single-hole punchers that come in different sizes. Watch my previous video on front panels to see how these can be easily modified to allow exact positioning. For the microphone hole, I'm using the same method but a smaller punch. While these are really brilliant, they have a very short reach, as you can see, and sadly it is impossible to use them for the two holes needed for the pressure and light sensors. For these holes I'm using a traditional punch for leather, which needs a piece of card underneath the laminated sheet to work properly. It has more reach and a selection of hole sizes, but the largest is just 4.5 mm, a bit on the small side for these sensors. The other problem is that it's hard to position accurately because it blocks you from directly seeing the mark where the hole should be, and it needs a lot of force to operate. Well, here you have the result, two usable front covers for the Enviro station. And now we're down to just one, because I tried to widen the hole for the light sensor using a drill bit, which is a very delicate operation, and of course messed the first one up. This one is okay. The enlarged hole has a bit of a rough look, but it's hardly noticeable. And that's all there is to it. I promised this one would be short. I include the front designs, the boring one you see here and the more fun one, in the files you can download from my GitHub page, link in the description. Thanks for watching.